Hello, in this video, we're going to be looking at lesson 7.4, applying properties of similar triangles. This section goes pretty quickly, so I'm going to do the first half of 7.4 and the 7.4 second part, the day 2 part, all in the same video, and it will still be less than 20 minutes. The essential questions that we'll answer are: how do you use properties of similar triangles to find segment lengths? And how do you apply proportionality and triangle angle bisector theorems? The triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. And remember that proportionally means that it divides them in the same ratio. So the diagram here gives us that line XY is parallel to segment AC. And we can conclude with the triangle proportionality theorem that the ratio of BX over XA, which is kind of the left side here, is going to equal the ratio of BY over YC. Just to make this a little bit more clear, let's add some numbers in here. So BX is 5 and XA is 2. And then let's say BY is 10 and YC is 4. So what this is stating is the ratio of 5 over 2 is going to be equal to the ratio BY over YC, which is 10 over 4. Now, this is the triangle proportionality theorem. Next, we're going to do its converse. So if this is the original theorem, it can be written as an if P then Q statement. For the converse, we have to switch the hypothesis and conclusion to if Q then P. So now we'll go the opposite direction. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. This one has the numbers in here already. So X or BX over XA is 3 over 1. And then BY over YC is 6 over 2. And both of those reduce down to 3 over 1, because 6 over 2, if we divide by 2, it's 3 over 1. So if I have these, 3 over 1 equals 3 over 1, we can conclude that line XY is parallel to segment AC. Let's try an example now. We're going to apply the triangle proportionality theorem to find some missing side measurements, and we'll round to the nearest tenth if necessary. We want to find the length of CY. CY is this piece right here. So I'm going to put a variable there. I'll just call it X. And if we apply the triangle proportionality theorem, what we would have is AX over XB equals, and then the other side is divided in that same proportion, and I have to make sure that I'm going from the vertex of the triangle on down. So it's going to be AY over, and then CY is what we are trying to find here. Subbing in our values, that's going to be 9 over 4 equals 10 over X. And now it's a proportion, so we can solve it using cross products. 9 times X equals 4 times 10. So 9X equals 40. Grab a calculator and divide each side by 9. And when you do that, you're going to get 4.444 repeating, right? Well, if I want to round to the nearest tenth, that's one decimal position. So CY is equal to 4.4. And there's definitely more than one way that you can set up your proportion. Like, for example, I could have gone the other way and said 4 over 9 equals X over 10, and I would still get the same answer. The way I wrote it the first time, though, is the way that matches the proportionality theorem in your notes. Go ahead and try the try now on your own. This one should divide evenly, so you won't have any decimals in your answer. Please pause the video now and calculate the length of DG. All right, here is your solution. 32 over 24, so I'm going this way, is equal to 40 over x. Use the cross product property and you should end up with DG equals 30. For this next example, we're going to verify that the segments are parallel. So to do that, we're going to need to use the converse of the triangle proportionality theorem. If we can show that this piece right here, that XW, divides the sides of the triangle proportionally, that will prove that they're parallel. So let's start by checking some ratios. So I'm going to begin on this side. And remember, I always go from like the vertex up here on down. So that's going to be the ratio of Vx over Xu. And you can see that that is 15 over 6. And then let's simplify our fraction. If we divide each by 3, or we use the fraction button on our calculator, we'll arrive at 5 over 2. Let's see if the other side is divided in the same ratio. So I got to make sure that I go the same direction, which is from kind of the top of the triangle, or the vertex here on down. So I'm going to go 45 over 18. So that is VW over WT. And subbing in our values, that's 45 divided by 18. If you simplify this fraction, both are divisible by 9. And that does simplify to 5 over 2 as well. So since these two are proportional, so since the ratio of Vx over Xu equals Vw over Wt, we know that segment Tu is parallel to segment Wx by the converse of the triangle proportionality theorem. Let's move now to another theorem. So the proportionality theorems do not have to be in a triangle. It can also be used when you have 3 or more parallel lines that intersect 2 transversals. So here I'm not forming a triangle. It's just 3 parallel lines. You can see how they're marked right here. I have 3 parallel lines, and then I have my 2 transversals. So this is a transversal 1. And a second transversal that we have is this one. So there's 2 transversals. This theorem tells us that if 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally, which again means in the same ratio. So let's go ahead and just use the A and the B that you see in the pictures. So transversal 1 is divided into A and B, and then transversal 2 is divided into C and D. So this theorem tells us that the ratio of A over B on transversal 1 is equal to the ratio of C over D on transversal 2. That's what proportionally means. It means that they're in the same ratio, and if you're trying to find a missing value, you can use a proportion. So with this in mind, let's move on to example 3. In this example, we're going to apply the 2 transversal proportionality theorem to help us solve this real-world problem. An artist used perspective to draw guidelines to help her sketch a row of parallel trees. So the row here, the parallel trees, are these red lines. So what we know from the picture is that all 4 of those are parallel. She then checked the drawing by measuring the distances between the trees. What is LN? All right, let's go ahead and start. So notice first that LN is all the way from here to here. So LN is what we're trying to figure out. So I'm going to put like an X there. That's my goal, to get LN. And on the other transversal, so I'm thinking of this as like one of the transversals. On the other transversal, I'll call this top one transversal 2. that corresponds with D to B. Because notice how they use the same parallel lines. I'm looking at BL and DN. Then we can also look at this 2.4. And notice that I do have a match for the 2.4 on the other side. It is 2.6. So using our two transversal proportionality theorem, we know that dB, so I'm kind of going to go from this direction here. So I have dB over BA. And on the other side, that is going to correspond with same direction. So we're going to go equals, and then it's NL, that's the blue piece up top, over, and then it is LK. And now let's go ahead and sub in our values. First, notice that dB is not given there, but if we just do the segment addition postulate, BD is going to just be this 1.4 and the 2.2 put together. So I'll add those up, 1.4 plus 2.2, and that is 3.6. So BD or DB is 3.6. BA, we can see, is the 2.4. And then on the other side, NL is our X value. That's what we're trying to figure out. What is LN or NL? And then that is over the 2.6 LK. So now it's really just a cross product here. So you're going to grab your calculator, take 3.6 multiplied by 2.6, and that's going to equal 2.4 times X. Multiplying that out, you get 8.64 equals 2.4x. And then we'll just divide by 2.4 to get that x alone. And it ends up being exactly 3.6. So that is the length of LN. So LN equals, and then we're going to put a unit in there because all of our measurements are in centimeters. So the length of LN would be 3.6 centimeters. Here's a try now. I'm going to let this one be one for you to try on your own. Pause the video now, and then when you hit play again, I will have the solution posted. Please pause now. All right, here is your solution. You should have gotten AQ equals 25.6 yards. You could solve the proportion either of the ways. The first way, I went from left to right. And the second way, I went from right to left. The final theorem of this section is called the triangle angle bisector theorem. This theorem states that if a ray bisects an angle of a triangle, then it divides the opposite sides of the triangle into two segments that are proportional to the other two sides of the triangle. So let's look at what this is saying. If a ray bisects a angle of a triangle. So here is that ray I just outlined in green. So that is like my angle bisector. So that's my ray that's bisecting the angle. Then it divides the opposite side of the triangle, like the opposite meaning across from that angle that's bisecting, into segments that are proportional to the other two sides. So notice how it's divided into like segment E and segment F. Well, what this theorem is stating is that E over F is going to be equal to the same ratio as the other two sides of the triangle that aren't being divided. So that's going to be G over H. And I went left to right each time. As long as we go the same direction, it works. Now let's look at this example here. You could certainly go straight to writing the proportion, but for this first example, I'm going to use the letters to kind of match the theorem up above. So the ratio of the angle bisector here that's dividing this into two equal parts. So that's the x and the 6. So LP divided by PN has to be equal to the ratio of the other two sides of the triangle, which are these two. And again, I'm going to just start with letters. So that's ML over MN. And now when we sub in our values, that is x over 6 equals x plus 3 over 10. And now we can just go ahead and solve that with cross products. X times 10 equals 6 times x plus 3. And remember, the whole thing's multiplied, so there's parentheses around the x plus 3. We're going to have to distribute. So 10x equals, and then it's 6x plus 6 times 3 is 18. I'm going to move the 6x to the other side. And that is 4x equals 18. We'll divide by 4. And when you do that, you will get 4.5. Now, careful, the directions do not ask us to find x. They ask us to find LP and LM. Well, LP is just the x value, which is just 4.5. And then LM is x plus 3, so we're going to need to do 4.5 plus 3. And that gives us LP is 4.5, add 3 to that. LM is going to equal 7.5. Here's a final example for you. It's a try now, and it's very similar to the one that we just looked at. You are going to apply the triangle angle bisector theorem to solve for x. And then once you have your x value, you're going to use that to find EF and FG. Please pause your video now and give this a try. All right, here is your solution. X should be equal to 4. And then you can plug that into the expressions in the picture. EF is just x, so EF is 4. FG is x plus 2, and 4 plus 2 is 6. That's all for this video. Thanks for watching, and good luck as you try some problems on your own. Bye.